Okay, we have been talking about the modeling of YD1 transformers. So, let us continue with that. We have already drawn the vector diagram and we have already drawn also the circuit diagram based on that vector diagram. So, now let us say that this is point N, let us say that Z is the per unit, and again here root 3. So, then Z is the transformer leakage impedance, transformer leakage impedance. Now, because now this point potential is VA, VB, V capital C, and this point potential is Vn. And but the problem is that because it is not grounded, so then therefore we do not know what is the value of Vn. So we have to eliminate it somehow. So to do that, what we do is, now if we consider a loop, so we take a loop current I1 in this loop. So basically the loop is A, N, C, then let us say ground to ground, right. So then therefore we consider a loop current I1 in the loop phase A, neutral point N, phase C, then ground through ground, and then we consider another loop current I2. So this is basically phase C, then our neutral, phase B point, then ground through ground. So we considered these two loop currents. Now what we write is, now suppose, so now from this, so now in this arm I can write down that VAN is equal to VA minus VN, that would be is equal to the drop due to the current plus the reflected voltage of the secondary side at the primary side. So now this drop due to this current is Z into I1, and the reflected voltage here is VAB by root 3, correct. So it is Z I1 plus VA by root 3 minus VB by root 3. And now if we look at this term VNC, so that is Vn minus Vc. Now in this branch the net current flowing in this direction is I1 minus I2. So the drop due to this current is Z into I1 minus I2, plus in this direction my voltage drop is, now this line is actually parallel to this line, so then it will be VAC by root 3, VAC by root 3. So it is Z into I1 minus ZI2 plus VA by root 3 minus VC by root 3. So then therefore, if I now add these two equations, so then therefore VA minus VN plus VN minus Vc. So this VN cancels out. That would be 2 into ZI1, 2 into ZI1 minus ZI2 plus 2 VA by root 3 minus VB by root 3 minus Vc by root 3. So I can write down this equation as VA minus Vc is equal to 2Z I1 minus Z I2 plus 2 VA by root 3 root 3. So let's say this is equation 1. Now, so then therefore, we have basically written down the equation considering loop 1. So this is essentially considering loop 1. Now, if I consider loop 2, considering loop 2, so VCN, VC minus VN, so now VCN, that is VCN, that is VC minus Vn is equal to, now here when we are talking about VCN, so we are actually starting from this point and basically moving towards the neutral point. So then therefore in this direction net current is I2 minus I1, so then the drop is Z into I2 minus I1, so the drop is Z into I2 minus I1, and the reflected voltage in this direction would be VCA by root 3. So it is VCA by root 3. So it is basically Z into I2 minus Z into I1 plus VC by root 3. And if I now go from point N to point B, so VNB, so VNB is equal to Vn minus Vb is equal to, now the drop in this direction, now in this direction the current is I2, so the drop is ZI2 plus the drop in this direction is, now essentially, so now we have got this drop as Z into I2, and now we have to take into account the reflected voltage from the secondary side, and because this line is parallel to this line, so then therefore our reflected voltage from the secondary side is VCB by root 3. So it is VCB by root 3. So therefore it is Z into I2 plus V small c by root 3 minus V small b by. So if I now add these two, so then therefore I get Vc minus Vn plus Vn minus Vb. So if I add these two, so I get minus Zi1 plus 2Zi2, then minus Va by root 3 minus Vb by root 3 plus 2 V small c by root 3. So Vn cancels out. So what is remaining is V capital C minus V small b to V small c by root 3. So this equation we say that this is equation 2. So now what we have so far achieved, that we have considered two loop currents I1 and I2. One loop current I1 is between phase A, neutral point, phase C, and then ground coming back. and then the another one is between phase C, neutral, phase B, and then ground, and then coming back. And then in these two loops we have written down the equations, and from those equations we have got now two equations, equation 1 and 2. Now in this we can see that I have got now two unknown loop currents I1 and I2, and we have got two algebraic equations uh, involving I1 and I2, equation 1 and 2, and basically these two algebraic equations are nothing but linear equations. So then therefore we can simply solve them analytically. So I mean, let us try to solve them. So to do that, what we do is first that we first do to solve this. Now we multiply first equation by 2 and then add it to second equation. So now by 2 into 1 plus 2. So if I multiply first equation by 2, so the left hand side is 2a, 2 into Va minus 2Vc. So 2 into Va minus 2Vc, capital C, and then so and from this, so V capital C minus Vb. So this is the left hand side, and then it is 4zi1 minus 2zi2. So it is 4zi1 minus 2zi2, and then it is 4 minus 2 minus 2 plus 4 Va by root 3. And now we add them. So this is basically 2 into I1 at the right hand side. Now this left hand side is Zi1 plus 2Zi2. This is from equation 2, and then minus Va root 3 minus Vb root 3 plus 2Vc by root 3. So just to notify it, so this portion is nothing but 2 into 1, and this portion is nothing but equation 2. It is equation 1, equation 2, and we are adding them. Okay. So now this cancels out. So 3zi1, so 3zi1 from this at the left hand side, 2V capital A minus V capital V minus V capital C, that would be is equal to 3zi1 and 4Va minus Va, so 3Va by root 3, so root 3Va, and then minus 2Vb minus V minus 3V, so sorry, this would be plus 4Va minus, so plus, and this is minus root 3Vb, and then this and this they cancel out, right? So therefore from this I1 I can write down that y by 3 into 2Va minus Vb minus V capital C minus root 3Va plus root 3Vb, where y is equal to 1 by z. Alright, so therefore I can write down I1 is equal to 2Va minus Vb minus V capital C by 3, then minus VA by root 3 plus VB by root 3 whole into Y, right? So this is my cell equation 3. Okay, so I1 is equal to this. So we have solved for I1. So similarly, we have to solve for I2. So let us solve for I2. So for solving I2, what we do is we do again by 2 into equation 2 plus equation 1. So 2 into equation 2 is 2VC minus 2VB. So 2V capital C minus 2V capital B and plus 1. So VA minus VC plus V capital A minus V capital C. That would be equal to, so minus 2ZI1 plus 4ZI2. So minus 2ZI1 plus 4ZI2 and then minus 2VA minus 2VB plus 4VC. So minus 2VA by root 3 2VB by root 3 plus so this plus 1. So 2ZI1 minus ZI2 minus ZI2 plus 2VA by root 3 minus VB by root 3 plus 2VA by root 3 minus VB by root 3 so this is it. So this we again note that this part is 2 into I2. So this is 2 into equation 2 and this part is equation 1. So equation 1 is 2ZI1 minus ZI2 2VA by root 3 minus VB minus VC. Right. So let's see what happens. So then therefore from here I can write down VA minus 2VB and then plus V capital C is equal to something will go down. So 2ZI1 goes out. So 3ZI2 and now 2VA by root 3 and plus, so these also goes out. So and then minus 2VB and minus 3, so it is minus VB by, no, it is so minus 3VB by root 3 minus, that means minus root 3 into VB. So it is minus root 3 into VB and then plus 4VC minus, so plus root 3 into VC. So therefore I can write down I2 is equal to Y by 3 is equal to VA So I can write down directly actually. Okay, so VA minus 2V capital V plus V capital C, and then plus root 3 VB root 3 VC. So therefore I can write down I2 is equal to VA Y VA minus 2VB plus V capital C by 3 plus VB by root 3 minus right. So this is the expression of I2. So you have got the expression of I2. So we have solved for this two equations. So we have solved for the currents I1 and I2. Okay. Now from these currents, now if I look at, now you see, if we look at the current here is I1, this is IA. So in this, so everything's now, if we look at this diagram, so all these currents are entering IA. So this is current IB and this current is IC, right, at the primary side. So then therefore I can write down I capital is equal to I1. So then therefore from this, so now I capital A is equal to I1 is equal to Y into 2VA minus VB minus VC. So 2VA minus VB minus VC by 3 minus VA by root 3 plus VB by root 3. So minus VA by so let's say that this is equation 5. Okay, so from this equation, now from this diagram, so let us write down. So IA would be is equal to I1, IB would be is equal to minus I2, and IC would be equal to, in this direction, so I2 minus I1, correct. So this would be the current relation. So this we were actually using. So IA is equal to I1. So we have already done it. So IA is equal to I1. So now IB is equal to minus I2 is equal to Y. I2 is this, so Y. So it would be minus VA plus 2VB minus V capital C by 3, and then it is minus VB by root 3 plus V small c by root 3. So this is equation 6. Okay, and IC, I capital C. So I capital C is I2 minus I1. So this is I2 minus I1. So Y, so I2 is Y. So we take common VA minus 2VB plus B capital C by 3. So I2 is this, plus BB by root 3 minus BC by root 3. Now minus I1. I1 is this. So we have already written minus 2VA minus VB minus V capital C by root 3, sorry, by 3. This is I1 and this is minus, so plus VA by root 3 minus VB by root 3. So this is IC. So now let's see if something cancels out or not. Obviously here this one cancels out, VB and VB, this and this, they cancel out. So here I'll be, and here, so VA minus 2VA, so it is minus VA by root 3. So it is minus, so then therefore I can write down I capital C will be Y. Now it is VA by 3 minus 2VA by 3, so it is minus VA by 3 and it is minus 2VB and then plus VB, that means it is minus VB by 3 and then it is plus VC plus 2VC by 3. So it is, so then therefore minus VA, so then it would be is equal to minus VA, then for minus 2VB plus VB, so minus VB, and then here VC and plus VC, so plus 2VC, and then by 3, and then it is VA by root 3 VA So this is equation number 7. So therefore we have been able to find out the expressions of 3 primary side currents IA, IB and IC in terms of the 6 voltages. Okay. Now to complete the model, we also need to find out the expressions of I small a, I small b and I small c in terms of all the 6 voltages, and then and only then we would be able to write down the full model. So that we will continue in the next lecture. Thank you.